Today we have this copy of Pokémon Pinball sent in for repair. It also comes with this neat 3D printed battery door that I'm assuming is a replacement for the original one. I thought that was pretty cool. Now the owner of this game says that it sometimes boots, but most of the time it doesn't, so let's go ahead and throw it into this SP and see what happens. So as you can see, it loads to the Nintendo screen, which is a good sign, but it gets stuck on this white screen. And if I try again, we can get it to boot to this weird glitchy blue screen, but again, no gameplay. So now we need to open it up by removing these two screws to see what the PCB looks like. At first glance, the top of the PCB doesn't look too bad. It could just use a cleaning as there's some possible flux residue left over from a previous repair attempt. On the back, however, we can see this giant patch of corrosion. It is right underneath the battery tab, so odds are this is just from a leaky battery that was left in. We can remove it using a scalpel blade, and as you can see, the copper shines right through, so I doubt this is causing any broken connections yet, but it's important to remove it before it does. I did try reflowing every solder joint on this PCB to see if that's all this game needed, and it still did not boot. So next thing I'm going to do is remove all the components on the PCB to see if there's any damage hiding underneath. This may seem like overkill, but that's kind of my channel. Under the microscope, you can see that there are a few vias that have solder inside of them. Now this is a common repair practice that is used to repair broken vias by just flooding them with solder in hopes that it'll reconnect the trace in between. I personally don't like doing this, as you can't see whether or not the damaged trace or the damaged connection between the vias repaired. That's why I like using 30 gauge wire fed through them, soldered on both sides. That being said, this method does work as long as you're sure that the solder is touching both sides of the PCB. I know I just said I don't like using the solder fill method to repair broken vias, but someone already tried that on this PCB and I want to see if I can finish it. Also, it would be nice not to use 30 gauge wire for a repair for once, as the last time we repaired every via with wire turned out to be a daunting task. However, it was fun. I just want to see if I can get away without doing it this time. So I loaded up the PCB with flux, and now I'm just filling every single via with solder. With the bottom vias all touched up, we flipped the PCB over. Now we're just going to add solder to the top side of those vias in hopes to increase our chances of making a good connection. As you can see, the top layer of the PCB doesn't have a whole lot of copper exposed around the vias. I'm not too sure if this will pose a problem. I guess we'll just have to wait and see. Now it's time to resolder every single component. Now it's time to see if all that work paid off. I'm going to go ahead and put the PCB inside the cart, and then the cart inside the Game Boy. And it did not work. And I kind of have an idea as to why that didn't work. If we look at the anatomy of this open via, you can see that it's made up of three parts. We have the top PCB layer, which has the small conductive ring, the conductive feed through, and then the bottom PCB via, which is another small conductive ring. Now what we're trying to achieve here with this method is we're trying to get solder to flow through all of this and essentially touching every single part, so the top, the feed through, and the bottom. Now I don't think that's happening with the top layer of the PCB. As you recall, there was that weird white solder mask that didn't have a whole lot of copper exposed around the vias, and I think this is what's actually preventing us from getting a solid connection. So what I think is happening is the solder is flowing through the bottom, through most of the tunnel, and then once it's getting to the top, it's actually having like this weird concave fillet to where it's just kind of stopping right about here, doing like a weird concave and stopping right about here. So it gives the illusion that it's connected, but it's not really making a strong connection. Now we could add more solder in hopes that it'll fix it, or we can go the extreme route and remove all the components again, remove all the solder mask, and then try again with just bare copper. Which of course we're gonna do. With all the components once again removed, we can go ahead and put the PCB inside of a dish, fill that dish with water, and start sanding. The water helps prevent the dust from becoming airborne, but I do recommend wearing a mask anyways, just in case. There are chemicals that can remove the silkscreen and solder mask, but I prefer just using sandpaper as it doesn't involve any kind of chemicals that I'm bringing into my home, and it's just easier to do, especially on a small PCB. All we're doing is we're just removing the silkscreen and the solder mask and exposing that sweet bare copper underneath. It is possible to burn right through that copper if you're not careful enough, so I do recommend giving this a practice on some scrap circuit boards if you have any lying around, and just kind of honing that pressure versus knowing when to stop ratio, because you can expose the copper and keep going and just go right through it. I've done it in the past. It's easy to fix, but it's easier to avoid it if you know what you're doing. And just like that, all the copper that we need exposed is exposed. So now we can go ahead and touch up these vias once again, and right away you can see some of those solder joints look a little concaved, and I think this is why the game isn't booting. At least I hope so anyways. So I'm just going to go ahead, add flux to every via, and touch up all the severely concaved ones, and just hope that this works, as I don't want to put the components on and take them off again for a third time. During the second removal of the components, I accidentally ripped up two pads, so I'm going to go ahead and repair those using 30 gauge wire. I'm just going to go ahead and tack them to a via and then to part of an exposed trace. Since we removed the reference designator for all the components on the PCB, it's a very good idea to take high quality photos before doing so that way you can look back on those and understand where the components are going and the orientation of them, as you don't want to mix up capacitors with resistors or put chips on backwards. I've used 30 gauge wire in the past to replace broken pads. It's very easy to do once you've done it a few times. It does add height to the overall chip, so you kind of want to make sure that you're not exceeding a certain height and that every pin is touching the pad. I like to solder the wire and then wiggle it around using a scalpel to make sure that it's not going anywhere. Everything is soldered on, excluding the motor control circuitry, these two battery tabs, and the little battery itself. Those aren't necessary for gameplay. I don't think they are anyways, so we're going to go ahead and see if we finally fixed it after stripping away the silk screen and touching up those vias a bit better. So let's plug it in. And alright, cool. I have no idea what I'm doing. I'm not gonna lie, I've never played this game ever. But it works, and that is all that matters. So now I can go ahead and finish up the PCB and clear coat it and send this off to the owner. Exposed copper on a PCB is just asking for trouble, as the copper can break down and lead to broken traces. So we're gonna have to cover that all back up with something. But for now, I'm going to tape off the areas I don't want to cover up, such as the battery contacts and the cartridge contacts. And now we can go ahead and lather on some thick layers of conformal coating. Finally, we can go ahead and put the battery tabs back on, install a new battery, hook up the rumble motor, and send this thing out. That's it for this video. Thank you guys so much for watching. I hope you enjoyed. Thank you to Hako for sponsoring my channel. They gifted me this amazing 3-in-1 soldering station that was responsible for this repair. Thank you so much for watching, and I will see you next time.